All right, welcome. Today, we're diving deep into the very heart of electrical safety, circuit protection. Look, for any professional, knowing your tools is everything, right? And in the electrical world, these devices, they are your most critical tools for keeping systems safe and reliable. So, let's get right into it. You've seen them all, lined up in switchboards, sitting on schematics, MCB, RCD, RCBO, MCCB. They look pretty similar. They all seem to trip, but here's the thing. They are absolutely not interchangeable. Answering this question, what's the real difference and which one do you use where? That's exactly what this is all about. We're going to move from just knowing the names to really, truly understanding the job they do. So first question, why do we even have so many different types of these devices? Well, the simple answer is that not all electrical faults are created equal. You've got overloads, you've got short circuits, and you've got earth faults. Each one poses a totally unique danger, and so each one needs a specific type of hero to step in and stop it. The core mission is always safety, but the strategy, that has to match the threat. And this slide really breaks that mission down beautifully. We're not just protecting a bunch of wires here, we are protecting the four pillars of any electrical installation. First, and this is the most important one, people. Then you've got the cables, which are like the system's arteries. After that, the expensive equipment that's connected to it. And finally, the overall health and integrity of the entire system. Every single device we're about to cover serves one or more of these pillars. Okay, let's start with the most common threats out there, overcurrents. Now, that includes those slow building overloads and the really violent, instantaneous short circuits. These are the main culprits behind equipment damage and electrical fires, and the devices we're about to look at, this is our first line of defense. The classic showdown, the old guard versus the new. Think of a fuse as a noble martyr. Its tiny internal filament melts and literally makes the ultimate sacrifice to save the circuit. It's effective, for sure, but it's a one-and-done deal. The MCB, on the other hand, is more like a vigilant guard. It uses an internal switch to trip the circuit, and the best part is, it can be easily reset once you've cleared the fault. No replacement needed, just a quick flick of a switch. And here it is, the humble miniature circuit breaker, or MCB. If you've ever worked on a modern residential or commercial installation, you know this little guy intimately. It is the absolute workhorse of final circuit protection. So, the crucial thing to remember here is that an MCB is all about detecting overcurrent. That means both those gradual overloads and the sudden short circuits. Its primary job is to protect the cable and whatever equipment is plugged into it. That's exactly why you see them on pretty much all final circuits, for your lights and power outlets. Now, what happens when the currents get bigger and the demands get tougher? Well, we move up to the MCB's bigger, tougher sibling, the molded case circuit breaker, or MCCB. And just like the name says, it's housed in this super robust case, and it's built to handle the heavy-duty demands of much larger systems. So just like the MCCB is looking for overcurrents. But its home turf is in high-power industrial and big commercial systems. One of the key features that really sets it apart is its adjustable trip settings. Now, this is absolutely critical in industrial settings because it lets you perfectly match the protection to, say, a specific motor startup current or coordinate with other breakers downstream. That way, only the breaker closest to a fault actually trips. And this chart just illustrates that difference in scale perfectly. An MCB, it typically caps out around 125 amps. An MCCB basically starts there and can go all the way up to 1600 amps, sometimes even higher. We're talking about a completely different weight class here, designed for the biggest electrical loads you can imagine. Okay, so we've covered protecting our cables and equipment from overcurrent. But what about the most important pillar of protection, people? Well, that needs a completely different kind of detection. We're looking for more insidious threats now. Earth faults, which are the main cause of electric shock. And this is the residual current device, or RCD. Its mission is singular, and it is absolutely vital. It saves lives. It honestly doesn't care about overloads. What it does is constantly monitor the current flowing in and out of a circuit. If it detects even a tiny imbalance, which means electricity is leaking out somewhere, maybe through a person, it trips in milliseconds. That's long before a fatal shock can even happen. Now, this is a really common point of confusion, so let's clear it up once and for all. An RCD, all by itself, only gives you earth fault protection. It's completely blind to overloads and short circuits, which is why it always has to be paired with an MCB. The RCBO, however, now that's the best of both worlds. It combines an RCD and an MCB into one single neat unit, giving you all three types of protection. It is your all-in-one safeguard. Okay, so far everything we've talked about has been automatic protection, devices that react to faults on their own. But there's another critical category, one that relies entirely on you, on manual operation, for a very specific and very important job: safety during maintenance. The key difference here, the thing you have to remember, comes down to one word: load. A circuit breaker is built to safely interrupt current. It can operate on load. That's its whole purpose. An isolator, however, is just a simple mechanical switch, and as the table says, trying to open it under load can be catastrophic. You can create a massive, dangerous electric arc. Its only job is to provide a guaranteed, visible air gap for maintenance, but only after the circuit has already been de-energized. Look, knowing what each device does is half the battle. The other half is knowing how to choose the right one for the job. So let's get into the practical side of things, selection, and some common applications. So, how do you make the right call? It's a systematic process, really. First, you calculate the load to size your overcurrent protection. Simple enough. Second, you determine the potential fault level. This is the KA rating or breaking capacity. It makes sure the device can survive a worst-case short circuit without, exploding. Third, you assess the shock risk to see if you need that RCD or RCBO protection. And finally, you have to think about discrimination. This is just coordinating your devices so that a small fault on a lighting circuit only trips the local MCB, not the main breaker for the entire building. Nobody wants a widespread blackout from one little issue. And here's how this all plays out in the real world. For your standard home and office circuits, an MCB or an RCBO for that added layer of safety is your go-to. For the heavy lifting on submains, you're going to use an MCCB. Now, in high-risk areas where people are more vulnerable, think bedrooms, aged care facilities, even EV charging stations, an RCBO is the professional standard. And of course, anytime you need to lock out a circuit for maintenance, you use an isolator for that positive, safe disconnection. I really want to pause on this because it is such a vital piece of professional wisdom. Just adding more breakers or picking the most sensitive device you can find isn't always the right move. Incorrect selection can lead to nuisance tripping, which just frustrates everyone. Or worse, it can fail to protect the system properly, giving you a false and dangerous sense of security. The goal is always, always correct protection. All right, let's bring it all home. We've covered the what, the why, and the where. Now, let's put it all together in a simple framework to make sure we're choosing the right device for the right fault every single time. Think of this as your decision-making cheat sheet. Is the main risk an overcurrent that could damage your cables? You need a fuse MCB or MCCB. Is the main risk electric shock to a person? Then you need an RCD or an RCBO. What if you need to protect against both threats in a final circuit? Well, the RCBO is your most efficient and effective solution. And finally, if you just need to guarantee a circuit is safely off for maintenance, an isolator switch is the only tool for that job. Simple as that. And that right there is the ultimate takeaway. Choosing a circuit protection device isn't like picking a part off a shelf. It is a fundamental design decision. It requires you to understand the load, the environment, and most importantly, the specific risks you need to protect against. So the next time you look at a switchboard, what are you going to see? A box of switches or a carefully designed system of protection?